Alright class, take out the sheet I gave you on your way out the door yesterday. It should look like this. Day 1, Part 2 of 4, Monday, April 16th. I'll give you a minute to take out this sheet. Now hopefully you worked this sheet last night, so right now you're just checking your answers as I go along. Let's see. When you look at this picture, we have an isosceles trapezoid, and we're supposed to find the length of LP. So we're supposed to find this length right here. Now, if we drop an altitude here and here, we can use our special triangle knowledge. This is a 45, 45, 90 triangle. So, there's a couple things we can do. This is the hypotenuse. If you look at the chart at the front of the classroom, what is supposed to be on the hypotenuse of a 45-45 triangle? Well, if you look on that chart, the hypotenuse says x radical 2. So, if I want to find out what the legs are, I could just divide by radical 2. So if I divide by radical 2 on both sides, that's going to give me x equals 3. That means this is 3 and this is 3. In the same way, over here, this will be 3 and this will be 3. By the way, over here we have an isosceles trapezoid, so if this is radical 18, that means this is going to be radical 18. What's going to be the length of this little piece right here? Well, that is going to be 5, because it's across from MT, which is 5. Well, let's not lose sight of what we're supposed to find. We're supposed to find LP. I think we have enough information to say what LP is right now. That's right, 3 plus 5 plus 3, that's 11. So the answer to number 1 should have been B. Okay, let's take a look at number 2. Number 2 is very similar, except for this time, if we drop our altitude right here, we have a 30, 60, 90 triangle. So let's see what we have. If this is 7, then this is going to be 7. If this is 6, then this is going to be 6. This is the short leg of the 30, 60, 90 triangle. If this is 6, what will the length of the hypotenuse be? Well, that's going to be 12. And again, if the short leg is 6, what will be the length of the long leg? That should be 6 radical 3. Now, we're supposed to find the perimeter of this shape. Of course, the perimeter is going to be the sum of all of these sides. Make sure when you're calculating the perimeter that you do not add this extra 6. So here's the sum of all the sides of that trapezoid, and you can see that that is 6 radical 3 plus 32, which would be the same thing as 32 plus 6 radical 3. Either way, that's going to be the answer to number 2. Okay, look at number 3. Multiple choice. which one of these could be used to find x? Well, looking at this 41, we've got the 41 and the 13 and the x. What trig function pops into your mind? Well, I'm hoping you would be thinking cosine right now, because looking at the 41, 13 is adjacent, x is the hypotenuse, so that would be cosine. Unfortunately, none of these choices involve cosine. They're all sine. So, are we stuck? Is there nothing we can do? Well, the problem is we're using the 41. But looking at options C and D, you see the 49. Where do you think this 49 is coming from? Well, look at this other angle over here. Remember, if we have one angle in the right triangle, if we want to find the other angle, we can just do 90 minus the angle we've got. So guess what 90 minus 41 is? That's right, so this angle is going to be 49 degrees. That means the answer is probably going to be C or D. Now let's take a closer look. So focus on the 49. So forget about the 41 for a minute. Focus on the 49 degrees. Looking at the 49, the 13 is opposite, and of course x is the hypotenuse. So opposite hypotenuse. That is in fact the sine function. So that sounds good since the sine function is all we've got. Now let's continue. So if we did the sine of 49, that should be opposite over hypotenuse. That should be 13 over x. So which is that, C or D? Well, that is option C. So that's the one that you should have chosen. So be aware of that. Notice when we first started we had this 41 sitting here, and we were supposed to subtract from 90 and actually use the angle that wasn't written in at first. So don't assume that you have to use the angle that's visible. There's a 50-50 chance that you're supposed to use the other angle. Okay, let's look at problem number 4. Okay, Bianca uses an angle measuring device on a 3-foot tripod to find the height of a weather balloon above the ground as shown in the diagram. Let's see how she did it. So we see the 40-degree angle is right here. A radio signal from the balloon tells Bianca that the distance between the tripod and the balloon is 25,000 feet. Now, focus on this. Where will this 25,000 go in the picture? Is it 25,000 along the bottom of this triangle, or is it 25,000 along the hypotenuse? Well, I'm hoping you're seeing that the 25,000 is the distance along the hypotenuse. The problem says it's the distance between the tripod and the balloon. Here's the tripod, here's the balloon. So 25,000 is this direct distance from one to the other. Okay, so we know the hypotenuse. Which expression represents the height, h, of the balloon? So we're supposed to find the height h. Now, temporarily, forget about the height h. We have this right triangle to work with, and we're going to be using sine, apparently. So, h is not part of the triangle. So let's call this x. X is very close to h. It's just going to have an extra bit added on the end. So let's concentrate on how we would find x for now. So let's see. Looking at the 40 degrees and the x and the 25,000, which trig function is that going to be? Well, 40 degrees X is opposite, 25,000 is hypotenuse. Opposite over hypotenuse, we're talking about the sine function, which is good because all of the answers involve the sine function. But let's go ahead and follow through. The sine of 40 degrees should equal opposite over hypotenuse, so x over 25,000. Now, we're not going to get any decimals, we just want an expression. How am I going to get x by itself? Am I going to swap the x and the sine 40, or do something else? Well, hopefully you were thinking that we would multiply both sides by 25,000. Because that's what we need to do. If we multiply by 25,000, these cancel each other out. So that's going to leave me with x is 25,000 times the sine of 40. Okay? Now remember, we're not trying just to find x. We're trying to find h. Now h is a little bit longer than x. How much longer is it? Well, it's just this little bit longer here at the bottom. And that is 3 feet, the height of the tripod. So if we want the length of h, all we need to do is take the length of x and add 3 feet onto it. And then, just like that, we have the length of h. So, the height of this balloon should be 25,000 times sine 40 plus the extra 3 feet. Which, looking across the answers, we see that that is B. Okay, let's go on to number 5. Okay, this problem involves a pattern that we memorized a long time ago, but you might have forgotten. Here's a right triangle. Remember that in a right triangle, these two acute angles are going to be complementary. No matter what, they have to add up to 90 degrees. Now, here's one that we've memorized. If this one is 30 degrees, what's this angle going to be over here? Well, that's going to be 60 degrees. They add up to 90. Now, here's the pattern that we memorized a while ago. If I do the sine of one of the angles, like the sine of 30 degrees, for example, that should equal the cosine of the other angle. So that should equal the cosine of 60 degrees. Okay, let's look at another one. Say if this is 40 degrees. What's going to be the measure of this angle down here? Well, that's going to be 50 degrees. Again, they have to add up to 90. Well, if the cosine of 40 degrees is what I begin with, that's going to equal, guess what I'm going to write over here? That should equal the sine of 50 degrees. So the cosine of one angle should always equal the sine of the other angle when they are complementary like this. Okay, so let's say one angle is 35 degrees. What's going to be the measure of the other angle? Alright? The other angle is going to be 55 degrees. Now this one you might have actually had to subtract because it's not quite as obvious, but just understand, if we're given one angle, we can find the other angle by doing 90 minus the first angle. So this angle came from 90 minus 35. Now, let's take that to an extreme. Say if I didn't actually know what this angle was at all. and I'm just going to call it theta. What's an expression that I could use for the other angle? Well, when it was 35, to find this angle, I did 90 minus 35. Well, since now it's theta, for this angle, I can say it is 90 minus theta. That's going to be my expression. Now, when the one angle was 35, we could say the sine of 35 degrees should equal the cosine of 55 degrees, right? The sine of one angle will equal the cosine of the other angle. Well, we can do the same thing with theta and 90 minus theta. So we can write the sine of theta should equal the cosine of 90 minus theta. Or we could have just as easily said the cosine of theta will equal the sine of 90 minus theta. Okay, so this is a principle that I've encouraged you to memorize. The sine of one angle will equal the cosine of a complementary angle. And we could write that as theta and 90 minus theta. Now, getting back to the paper, looking at number 5, it should now be obvious when you look at it which one of these matches what we were just talking about. Which of these is always true? Hopefully you're thinking D, because that's exactly the expression we were just talking about. Sine theta will always equal a cosine of 90 minus theta. But we can also use that to answer question number 6. Cosine of 71 will equal the sine of something. And so the question is, what would this angle be? Well, hopefully you can see the pattern even without drawing the triangle. Okay? If the one angle is 71, okay, so one angle is 71, the other angle is going to be 90 minus 71. So that's going to turn out to be 19 degrees. Okay, if one angle is 71, the other angle is 19 degrees. In that case, if the cosine of 71 should equal the sine of 19 degrees. So that means x must be 19 degrees. Okay, looking at number 7, it's very similar to the one we did above. If that's 7, this is 7. If that's 6, this is 6. It's not drawn to scale, but this is a 45-45 triangle. So if this is 6, then this must be 6, and the hypotenuse must be 6 radical 2. You're supposed to find the perimeter, so add all these up. Remember, do not add the 6 in the middle. This would be the sum of all the sides, and we get 6 radical 2 plus 26. So that's the perimeter. 6 radical 2 plus 26. Okay, let's see what else we've got. Alright, looking at number 8. Tangent of A. Looking at angle A, tangent is opposite over adjacent, so that's 20 over 21. Sine is opposite over hypotenuse, so that's 20 over 29. cosine of angle A. Still looking at angle A. Cosine is adjacent over hypotenuse, so that's 21 over 29. And the tangent of angle B. So now we're switching. Better change colors. So looking at angle B now, tangent is opposite over adjacent. So that's 21 over 20. Let's look at number 9. We're supposed to determine if these are true or false. Well, for problems like this, it's helpful to label these with x's and y's. So I'm going to call this side x, I'm going to call this side y, and I'll call this h for hypotenuse. Let's see, does tangent A equal tangent B? Oh, you know what? Hold on. I shouldn't have marked these different. I put x and y. Why should I mark these using the same variable? Well, hopefully you'll realize, because of the way these are marked, this is an isosceles triangle. So these two sides are the same. So if this is x, I should call this x as well. Now, if I do the tangent of angle A, that's opposite over adjacent. Well, that's going to be x over x. If I do tangent of angle B, that's opposite over adjacent. That's also x over x. So are those going to be equal? Well, sure. So that one is true. What about sine A and cosine A? Let's see, sine A. Opposite over hypotenuse, that's going to be x over h. Cosine A. Adjacent over hypotenuse, that's also going to be x over h. So that one is also true. Sine A cosine B. Sine A. Opposite over hypotenuse, so that's going to be x over h. Cosine B. Adjacent over hypotenuse, so x over h. That is also true. Now, will the measure of angle A automatically be 45 degrees? Well, yes it will. That's going to be true. Anytime you have an isosceles right triangle, it's going to be a 45-45 triangle. It's like half of a square. So all of those were true. Okay, let's move on down to the next one. So look at number 10. Let's see, what are we supposed to find? We have this picture given. They mention the radius of the base. Which expression represents the slant height? Now, what length in this picture do you think is the slant height? Do you think it's the altitude right down the center? Or do you think it's the hypotenuse right here? Well, based on the word slant, we know that it's going to be the hypotenuse down the side of this triangle. So that's the length we're trying to find. We have this 110 out here, but we really need to know what this angle is on the inside of the triangle. How am I going to find this angle that's on the inside of the triangle right here? Well, anytime you have a straight line like this, what's the total degrees formed when you have a straight line? Well, that's going to be a total of 180. So if this is 110 and I need a total of 180, how many degrees is this angle going to be right here? Alright, hopefully you can see that this is going to be 70 degrees. So looking up at the picture, do you see the two answers that involve 70 degrees? So the answer is probably going to be either A or C, because they are the ones that involve the angle inside the triangle. Now, to find this hypotenuse, we've got the 70-degree angle, and we've got 6, and we're finding the hypotenuse. Hopefully you can see that this is going to be the cosine function, because 6 is adjacent, and of course this h is the hypotenuse. That's cosine. Plus, all of the answers involve cosine, so you should automatically be led to cosine. So let's follow through. Cosine of 70 degrees. Cosine of 70, adjacent over hypotenuse. So that's going to be 6 over h. We need to solve this for h. What is the quickest way to solve this problem for h? Do you remember the shortcut that I reminded you of yesterday? We should be able to reverse and swap the h in the denominator with the expression cosine 70. So if I do that shortcut, what I get is h equals 6 over cosine 70. Now I'm only going to do that when the variable is in the denominator. If the h had been in the top, I would have just multiplied. So this is the expression for the hypotenuse. So that is C. That's why the answer to number 10 was C. Okay, look at problem number 11 and 12. I did one similar to this yesterday, so I'm just going to do this really fast. We have the sine of 3/4. So let's think about the sine of this angle. The sine of theta should equal opposite over hypotenuse. So that would be x over 24. Once we have this equation set up, we just cross multiply. So 4x should equal 3 times 24, which is 72. Okay, so x equals 18. Now look at number 12. Based on the fact that the theta is here, we're going to draw our right triangle here. N is the x value, so I'm going to put it horizontally. 14 is the y value, so I'm going to put it vertically. If I do the tangent, which is the function I'm given, that should be opposite over adjacent, so that should equal n over 14. If we cross multiply, we're going to get n equals 12. Okay? Alright, so that's the end of the sheet that you were given yesterday. Now take a look at the sheet that you were given today, the new sheet that you were given today. Some of you were probably even working on that sheet while I was doing this part of the lesson.